Hello everybody, this is Fire with the 8-bit machine. I'm probably gonna be a bit laggy here because there's so many gates here. And I want to show you how this works before I move into later stages and it gets more complicated. Right now what I've done is I connected all the memory. There are 256 bits, which is 32 bytes, and each byte has 8 bits, of course. On the left side you have the bits 0 to 15, so it's 0 right here, 1, 2, 3, and goes down to 15. Then it starts on 16 right here, and it goes down to 31. You can write to memory, of course the display is through these LEDs, that's how I know how it shows. And you can write to memory using these 8 switches, and you can select which memory you want to write in different ways. The first way is using these switches right here. This selects the binary address from 0 to 31, because you have 5 switches, so you can select from 0 to 31. And you have to activate this write enable. We need the write enable so we are not writing all the time. We are just writing to memory when this is active. The other way to activate the memory is through this numpad. These switches right here activate the memory using a decoder that is on that side, and I'm gonna show you how it works when we get down there. The numpad is more trivial, it's just a non-comparison gate per each switch, per each byte. You have 32 non-comparison gates, and they go from 0 up to 31. The other way to write to memory is using this switch right here. This one, what it makes is that it activates write to all, which means that whatever you have here is going to be fixed to all the memory. I'm gonna show you a couple of them so you can see how it works, and then we're gonna move down there. Let's say we want to modify this one right here. This is 15, so this one is 14, 13, 12, 11, and this one is 10. So we have to select 10 here. 10 is 8 plus 2, so it's 8 plus 2, that means 10, and we have to activate the write enable, and it all clears out because I have all this to 0. So let's write something here. You see, I can modify it how I want, and let's clear this out. You always want to put this off before moving to any different address. And then let's pick another one. Let's say we want to modify this one right here. This is 16, so this one is 17. 17 is going to be 16 plus 1. And let's activate it. You see? You can modify that one. Actually, that's better. I'm going to show you one with the numpad. Let's say we want to modify this one here in the bottom. This is 31, so let's just write 31 here. That's it. Put it all to 1. You see? This one doesn't have a write enable, so if you want to deactivate it, you have to put a number over 31, and that's about it. So I always use 50 for some reason, so I put 50 here. Well, actually any number over 31 will work. I'm not gonna test this because I'm gonna overscribe my smiley face, but this one does the same thing. I'm gonna show you how it works when we get down there. Okay, so now let's go to implementation. First of all, this is gonna be address 4, which is connected to switch 4 for 16, and this sends not address 4. This is using inverter. The same way, this one is address 0, and it sends not address 0. I'm gonna show you how it works on the decoder, and the same thing we're doing it with the data. This is gonna be data 0, and it sends not data 0. This is needed for the D latches, and this is the same out to data 7 and not data 7. Let's go on there. We're gonna start checking this decoder. This is a 5 to 32 decoder with a write enable, and it also have a write 12. With that, I did that recently. These 6 right here are memory address 0. But actually it's just this 5 right here, and this one is the whatever you have here is in an OR gate with write 12. So all of them are in an OR gate to write 12. So you activate write 12, all of them are going to activate. That's why it works. And they are all in an AND gate with write enable. So you have to be activating write enables for any of this to work. So if you have the number 0, you expect it to be when all the switches are off. So it's gonna be not address 4, not address 3, not address 2, not address 1, and not address 0. So that's what you have here: no address 4, no address 2, not address 2, yeah, no address 1, and not address 0. So let's just pick some other. This is 16, so this one should be 17. 17 is 16 plus 1, so you have address 4 and address 0, and all the rest are not. So you have address 4, not address 3, you have not address 2, not address 1, and you have address 0. And of course this is an AND gate with write enable, and this is a write tool. This is just a decoder. With a 5 to 32 decoder with a write enable and write tool. I'm also gonna make another video showing how the decoder works, and probably the latches and the RS latches and all that. So people who are not that familiar with this will understand. We're having to go into that much detail in this video. As I said, this left part are bits 0 to 15, and the right part are bytes 16 to 31. I put right here, this one is 0, which is the one on the top on the left side, and 16, which is the one right on the top on the right side. Right here is the write enable. So write enable for 0 activates when you activate the memory address for 0, or when the decimal address, which is the non-comparison gate, is equal to 0. And yeah, that activates the write enable for all the latches. Right here you have this is the latch. As you see, all these are 4 NAND gates working together. They all activate with write enable 0, and then this one receives not data 0 and data 0, and here's the output. The output is to pixel in 1 of pixel 0.7. That's just a naming that I did for these OR gates right here. And then this one will be data bit 1, this data bit 2. Let me see. 1, 2, 3, 4, 5, 6, and 7. So this one right here will have not data 7, write enable 0 still, because we're on byte 0. Then you have write enable 0 and data 7. Let's move to other one. This one, of course, is going to be the same thing. It's going to be from data 0 up to data 7 right here. Not data 7 this one, data 7 this one. But it's going, as you see, it's going to be activated by the write enable 16, because this is the byte 16. And again, the byte 16 activates when the write enable 16 activates when you have the memory address 16, or when the decimal address is equal to 16. Let's go a bit down. Let's go deeper in this. these are the ones on the bottom. So these are 15 and 31. You see that one is 14 and 30. Then up there you have 13 and 29, 12 and 28. So 15, of course, this is the same thing as all the rest. This one is the right enable 15 when you have the memory address 15 or the decimal address is equal to 15. This one will be data bit 6. So you have not this 6 with right enable 15, and you have data 6 with right enable 15. And yeah, that's about it. It's just like many connections and a lot of gates. Yeah, that's about it about this stage. The next thing I want to do is finish connecting the instruction part, because this is mostly memory used for information, but you need instructions to be able to do anything. So I'm planning on doing right now. I still on debate, but I'm planning on doing 12-bit instructions. It's gonna be like the same thing, but 12-bit long. So I'm gonna have to put another one here. This is still just like partially connected. It's somehow connected, but it's still not complete. It still needs a different decoder for this and all that. Yeah, I plan on doing different decoders, even though it's a lot easier to do that way here. This one already has 12 bits, or not. Yeah. Well, what I plan to do next is just connect all this, and when I have a working set of instructions, I'm gonna actually have to do a way to modify this one, but it's gonna work similarly. And then I have to do, actually not this one, I have more down here, and I have more down here. So yeah, and I have more down here. So yeah, after I finish all this, I also want to do different displays. Right now you have one display, as you see right now. This is showing what I have on memory, but I have to make a way to show what I have on the instruction part, so I have to do that part. And I actually want to have 5 sets of different displays. This first one is going to be an interface, which will be like the default. Then it will be some type of display in case I want to show some type of number or letter or symbol. Then it's going to be this, the memory, and then the instruction memory. I'm probably going to have to do 2 of instruction memory, because this one is 8-bit long, but the memory is going to be 12-bit long. So if I want to make 32 different addresses for memory, I'm actually going to have to take 2 screens. And that's it. That's how we are right now. When I finish the next stage, I'm going to make something similar like this. Probably it's not going to have as much tutorial as this one, because most of the stuff for instruction are similar. But I'm gonna have one probably to show how I go about doing different displays to the memory, how I can select the different displays I'm gonna do to the memory to the display. And that's about it. If anything, just thanks a lot for watching. I hope you enjoy it.